Hey there, and welcome to another deep dive. Today, we are plunging into something that, well, it crosses just about everyone's mind, how to live a longer, healthier life. And when you start looking for advice on this, especially online or, in popular media, you almost immediately run into the idea of blue zones.
Hmm.
These specific places around the world where people supposedly live much, much longer, often reaching age 100 and beyond
Yeah.
at rates higher than average. You've probably seen the articles, the documentaries like that one on Netflix, maybe even books, telling you to copy the habits of folks in places like Okinawa or Sardinia. It's really become the go-to source for longevity tips for a lot of people.
And the appeal is totally understandable, right? I mean, the idea of finding simple, accessible lifestyle habits practiced by these centenarians
Yeah.
and just applying them to your own life feels tangible, it feels achievable, it's a really compelling narrative. But the source material you've brought us today, it really challenges that entire premise. It suggests this popular approach might actually be fundamentally flawed.
Okay, yeah, let's unpack this then. Because reading through these sources, it seems their core argument is that relying on blue zone advice might actually, and I'm quoting the source here, a terrible idea. So our mission today is to dig into why the source says that, what the real issues are with the data behind these zones, and then crucially, what this material suggests we should be focusing on instead, based on what it calls better evidence. What does this source say is really important for extending your healthy lifespan? So maybe let's start with the basics according to the source. What exactly are these blue zones, and where did the whole concept come from?
Well, the term itself is actually only a bit over 20 years old. It came from research by Michel Poulain, who was studying longevity in Sardinia, the island in Italy. He specifically identified a region there with a, let's say, higher concentration of centenarians, people living over 100. The source notes that back in 2004, this specific area had about 16 centenarians per 100,000 people, compared to about 10 per 100,000 in the rest of Europe at the time. So yeah, the initial observation seemed interesting, but as the source explains it, the concept pretty quickly moved beyond just academic observation. Another person joined Poulain, and they actually went on to patent the name Blue Zones.
Wait, they patented the name?
Yes, patented the name, and after that, they identified other regions, Okinawa in Japan, Nicoya in Costa Rica, Ikaria in Greece, claiming they also had these unusual concentrations of centenarians. And from there, it really took off commercially. You had books, documentaries, even product lines. It basically became a global brand built around this idea.
Okay, so that's the concept and how it kind of exploded. But this is where the source material gets really critical, right? It doesn't just accept the premise. It challenges the evidence itself. What are the major data problems it points to?
Yeah, this is really the core of the source's argument against relying on the blue zone concept. And the problems highlighted are, well, they're quite stark. In places like Okinawa, for example, a government review was actually triggered by a case where a man supposedly over 100 was still being claimed as alive for his pension. But he had actually been dead for decades.
You're kidding me. Decade.
No, and this investigation, it uncovered really widespread fraud. The source cites official reviews showing that up to 82% of people supposedly over 100 in Okinawa were actually already deceased.
82%.
Yeah.
That's not just an error margin, that's a massive statistical distortion.
It's huge, exactly. The secret to longevity in those cases wasn't diet or lifestyle. It was simply that death certificates weren't being filed properly or at all. The source also mentions that some of the high counts claimed in Okinawa might be linked to lost birth records from WWII bombings, making it genuinely difficult to verify ages for some older people. And it's apparently not just Okinawa. The source looked at UN data over 72 years for other countries that consistently reported high centenarian numbers, places like Thailand, Malawi, Western Sahara, and Puerto Rico. And these countries also have well-documented issues with corruption and fraud in official records. So much so that some actually stopped using birth certificates as the sole legal ID document because they were just so unreliable.
Right. So drawing life lessons from data that the source basically describes as rotten, that feels problematic, to say the least.
It really undermines the whole foundation, and the source points out internal inconsistencies too. Like, take Ikaria, which is a designated blue zone in Greece. It's actually ranked 109th out of 128 regions in Europe for overall life expectancy.
Wait, hold on. So it's presented as this place where people live super long, but its general life expectancy ranking is actually quite low compared to other European regions.
Precisely. The source argues that it just doesn't make logical sense for a place to have a low overall life expectancy, but a supposedly massive concentration of the absolute oldest people,
No.
unless there's a serious issue with how those very old numbers are being counted or verified.
Okay, so to recap, we've got significant data fraud, lost records, these internal inconsistencies within the claim zones themselves. What does this all mean for you, the listener, who might have, seen that Netflix show or read those articles and thought, okay, I should do that?
Well, it means that much of the popular advice you encounter, which is derived from observing and replicating the supposed habits of people in these blue zones, is potentially based on statistics that are inaccurate, flawed, or in some cases, outright fraudulent. And this isn't just some academic debate for demographers, right? This kind of bad data influences real world things. Things like the cost of health insurance premiums, how governments make long-term plans for pensions and retirement ages, and even the standard health advice disseminated publicly by doctors or health organizations. If the foundational data is unreliable, the conclusions drawn from it and the advice given, well, it might not be accurate for truly extending healthy life.
Okay, so if copying habits from places with such questionable data isn't the effective path forward,
Mhm.
what does the source suggest is a more rigorous, maybe more data-driven way to approach personal longevity?
This is where the source really pivots. Instead of looking at potentially flawed population statistics elsewhere, it shifts the focus inward to measuring your own biological age.
Biological age. Okay, how is that different from my chronological age? The number of candles on my last birthday cake.
That's a great question. Chronological age is just, well, the time you've been alive. Biological age, as the source explains it, is a measure derived from analyzing your epigenetic profile.
Yeah.
Think of epigenetics as changes in the expression of your DNA, not changes to the DNA sequence itself, but kind of like markers or tags that affect how your genes are being turned on or off or how they're being read. These patterns accumulate over time and they're influenced by your lifestyle, your environment, your genetics, all that stuff. So a biological age test looks at these epigenetic markers to give you a snapshot of how well your body is functioning and aging compared to other people of the same chronological age, sex, and ethnicity.
Okay, that makes sense. It's kind of like measuring the wear and tear, essentially, relative to your peers. What are the advantages of looking at your biological age instead of just studying populations?
The advantages are pretty compelling for you personally, right? First, it gives you a real individualized comparison. Are you aging faster or slower than the average person like you? The source even gives an example of someone who measured their speed of aging and found it was like 24% slower than the average for their group. Second, and this is huge, I think, it allows you to see if specific interventions you're trying, say, changing your diet, taking a certain supplement, starting a new exercise routine, are actually working for you. Working in terms of slowing down your biological aging process now. You don't have to wait decades to see if some population study somewhere confirms a certain habits effect might work on average. This approach takes that generic health information, which can be confusing, and makes it specific and actionable for your body and your response.
Wow, yeah. That shift from generic, potentially flawed population data to personalized biological data is pretty dramatic, isn't it?
It really is. It puts the focus and the potential for measurement directly on you and your physiology. Now, the main disadvantage, the source mentions, of course, is the cost. Getting these epigenetic or biological age measurements done, it's not cheap yet.
Right. The cost is definitely a factor. Okay, so we've established why the blue zone concept might be misleading, introduced this idea of personalized biological measurement. Let's move on to what the source material says does show promise for actually increasing our healthy life expectancy, looking at specific biological factors and, areas where the science seems strongest.
Absolutely. So the source first touches on some factors that are perhaps less about direct lifestyle choices and more about underlying biology or very cutting-edge research. It mentions the clotho gene and the protein it produces.
Lotho, like the Greek fate who spins the thread of life. Is that where it comes from?
Exactly. That's exactly where the name comes from. Because this protein seems so important for the speed of aging in many mammals, and it's found at higher levels in some long-lived individuals. In mouse studies, for instance, increasing the expression of this gene has been shown to significantly prolong lifespan, sometimes by as much as 30%. That's huge. The source explains that the protein has several key functions related to longevity. It helps regulate how your body handles phosphorus and vitamin D, which is important for bone health, and preventing calcification in arteries. It also has antioxidant effects. It inhibits certain growth signals, like those that tell your cells to multiply rapidly, which can be linked to cancer. And it plays a role in modulating those epigenetic changes we talked about, the ones central to controlling how long an organism lives. Now, levels of clotho naturally decline as we age, and low levels are strongly linked to various age-related diseases, from osteoporosis to heart problems and cognitive decline. Things that we know can potentially increase lifespan, like caloric restriction, might help maintain clotho levels. And maybe some medications could play a role in the future, but that's still research. The source notes that this is a really active area of research. There are experimental gene therapies being developed to try and increase clotho expression in humans, and companies have even patented recombinant clotho protein itself to potentially administer as a drug.
So potentially revolutionary treatments down the line. But you mentioned the cost earlier with the testing. I assume these would be expensive too.
Oh, undoubtedly, yes. The source explicitly highlights this as a major concern. As we develop these technologies that could significantly impact lifespan at a really fundamental biological level,
Hmm.
there's a very real potential for creating profound health inequality based purely on who can afford access to these advanced treatments.
Yeah, that's a really challenging thought about the future of longevity, isn't it? But let's bring it back to things that are potentially more actionable right now for you, the listener. Focusing on the significant lifestyle impacts the source discusses.
Right. So while the source cautions that nothing has, irrefutable proof of extending maximum human lifespan yet, it points to several areas with really strong evidence for significantly reducing mortality risk and likely extending healthy life based on robust animal studies, human observational data, and increasingly human interventional studies too. First up is caloric restriction. Now, the source cites strong evidence in animal models, lots of different species, showing that eating around 30% fewer calories than needed for weight maintenance can increase lifespan by 20–30%. In humans, studies like the Big Calorie Trial, where non-obese individuals reduced their calorie intake by about 25% for 2 years, they showed significant benefits. Even without being overweight to start, participants lost about 10% of their body weight. They improved key cardiovascular markers like LDL cholesterol going down, HDL cholesterol going up, better insulin sensitivity, lower blood pressure, and showed reductions in biological markers linked to mortality risk. The proposed mechanisms are pretty well understood, things like inhibiting growth pathways like MTR and activating maintenance pathways like AMPK, essentially shifting the body from a state focused on growth and building tissue to one prioritizing maintenance, repair, and efficiency. And while it's obviously difficult to get that irrefutable lifespan extension proof in humans because it takes decades, the evidence presented makes it highly probable that smart approaches to calorie intake, even short of extreme restriction, can have a significant positive impact.
Okay, so it's not necessarily about, like, starving yourself, but being really mindful of intake and maybe aiming for a calorie deficit if it's appropriate and safe for you.
Exactly. And focusing on nutrient density within whatever calorie framework you choose. Next, the source puts a lot of emphasis on VO2 max.
VO2 max. Okay, that's your aerobic fitness level, right? How efficiently your body uses oxygen when you're really pushing it.
That's exactly it. It's your maximal oxygen uptake during intense exercise. And yes, it naturally declines with age, but the source stresses, and this is key, that it is highly trainable. You can improve it significantly. And here's the really important point it makes. A higher VO2 max is one of the single strongest predictors of lower mortality risk, even stronger than factors like smoking status, diabetes, or heart disease history in some big studies. And unlike many health parameters where there's a sort of optimal range, with VO2 max, there appears to be no upper limit to the benefit. The fitter you are aerobically, the lower your risk tends to be, pretty much linearly. The source gives a relatable benchmark. Being able to climb, say, 4 flights of stairs briskly without becoming breathless, that requires a VO2 max of roughly 45–50 milliliter. Below that, you'll likely get winded doing it. And training your VO2 max through regular aerobic exercise, including some higher intensity work like interval training, it specifically mentions the Nordic protocol, which is like 4 minutes at high intensity, followed by 4 minutes at low intensity, repeated maybe 4 times. Going that kind of training can reduce your mortality risk by a massive 20–40%.
Wow, 20 to 40% reduction. That's enormous.
It's huge. Converting that to years isn't exact for every single person, but for a typical individual, the source suggests it could potentially add something like 5 to 10 years of life. Plus, it significantly improves your resilience to illnesses like recovering from surgery or fighting off infections.
That's a huge potential payoff for something that's largely within most people's control through exercise. VO2 max feels like a really concrete metric to actually work towards.
It is, and the evidence backing its importance is really robust. The source also discusses sleep optimization. And here, it presents a kind of surprising finding, maybe. Large population studies often show the lowest mortality risk isn't necessarily at the widely cited 8 hours a night, but often closer to 7 hours. And the risk can actually increase faster when sleeping more than 8 hours compared to sleeping a bit less, like 6 hours.
7 hours. Okay, that does go against the common advice of always needing 8 hours, doesn't it?
It does seem to. But, and this is a crucial caveat the source adds, many of these large observational studies are likely confounded, meaning they include people who might be sleeping more because they are already sick or maybe depressed. And it's the underlying health issue, not the longer sleep duration itself, that's actually causing the increased mortality risk observed in those groups. So the key takeaway isn't necessarily sleep less is better, it's more nuanced. It's about focusing on optimizing the quality and duration of your sleep based on your individual needs and how you feel. Paying attention to sleep hygiene, consistency, maybe even measuring your sleep patterns can be a free and highly effective way to improve overall health and potentially longevity.
Okay, that clarifies the focus on quality and finding your optimal amount, not just blindly aiming for 8 hours or thinking 7 is magically better for everyone. What about diet? The blue zones always emphasize specific diets, don't they?
Yeah. They do, often plant-centric ones. But the source here takes a slightly broader, maybe more pragmatic view on diet. It suggests there isn't really one single longevity diet that's proven superior for everyone. Instead, it argues the most critical aspect is actually avoiding nutritional deficits. Just making sure you're consistently getting enough essential vitamins, minerals, quality amino acids from protein, omega-3 fatty acids, and other key micronutrients. That's paramount. It provides an interesting example breakdown for how one might integrate animal protein into a diet focused on nutrient sufficiency rather than prescribing total avoidance, like maybe beef 1-2 times per week, chicken 2-3 times per week, fish or seafood 3-4 times per week, which would still leave maybe 6 or 7 meals per week entirely free of animal protein, allowing for plenty of plant-based meals. And crucially, it distinguishes between processed meats like sausages, bacon, deli meats, which are consistently linked to higher mortality risk in studies, and quality unprocessed meats. It emphasizes that food quality matters significantly. The source acknowledges that dietary evidence can be complex, sometimes contradictory, and that reinforces the earlier point about personalization, figuring out what works best for you, perhaps using personalized data like blood work or even biological age tracking is likely key rather than just following a rigid, generic diet plan pulled from a book.
Right. So focus on getting all the essential nutrients, minimize the processed stuff, pay attention to quality, and potentially tailor it to your own body's response. Got it. You also mentioned some other promising areas of research that the source touches on, although maybe less proven or accessible for general use right now.
Yes, exactly. The source briefly highlights a few other areas that are more on the cutting edge, emphasizing they are still largely experimental or lack conclusive human evidence for general longevity outside of treating specific diseases. So think of these more as areas of future potential or active research rather than immediate actionable items for most listeners today. It mentions certain substances used for glucose control, like metformin, which is a common diabetes drug, or the newer SGLT2 inhibitors. There's observational data suggesting some potential longevity benefits, particularly in people with diabetes, but definitive proof for lifespan extension in healthy, non-diabetic people is still needed. It also mentions rapamycin. This is a drug with really strong animal evidence for extending lifespan. It works by inhibiting that mTOR pathway we talked about, kind of mimicking some effects of caloric restriction. But again, it's still undergoing testing in humans specifically for longevity applications. Then there's discussion of things like plasma dilution or plasmapheresis. This is an experimental therapy inspired partly by old animal experiments where blood was exchanged between young and old animals. The idea is to filter or dilute the blood to remove inflammatory markers and other harmful molecules that accumulate with age. There's some early human evidence suggesting it might reduce inflammation and potentially show signs of epigenetic rejuvenation, but it's very experimental. Substances called senolytics are mentioned too. These are compounds, like dasatinib combined with quercetin sometimes, that selectively target and destroy these senescent cells, often called zombie cells, that build up in tissues as we age and contribute to inflammation and dysfunction. There's some human evidence in specific disease contexts, like osteoarthritis, but it's still in the research phase for general longevity. And finally, NAD precursors like NMN are discussed. The idea is to boost cellular levels of NAD, which is important for energy metabolism, mitochondrial function, and DNA repair, and tends to decline with age. While these precursors might show positive effects on certain metrics related to aging speed, they haven't actually been proven to increase maximum lifespan directly in humans yet. The source also very briefly touches on epigenetic reprogramming using what are called Yamanaka factors. This is highly promising lab research showing potential to actually reverse cellular aging processes, but translating that into safe and effective human therapies is very experimental and likely a long-term prospect.
That's a really fascinating peek into the future and the cutting edge, even if it's not all ready for prime time just yet. So, bringing it all together then, the source material makes a pretty compelling case, doesn't it? That the widely popular advice stemming from these blue zones is maybe built on shaky, questionable data.
Absolutely. The source strongly argues that the real path forward for extending healthy human lifespan lies not in trying to copy potentially misunderstood habits from populations with dubious statistics, but rather in understanding the actual biological mechanisms of aging itself. It really advocates using tools like biological age measurement to track your individual progress and focusing on evidence-based interventions, particularly those accessible lifestyle factors we spent time on. Things like thoughtful approaches to diet and maybe calorie intake, rigorously training your VO2 max, truly optimizing your sleep, ensuring nutrient sufficiency. These are based on solid science showing they impact those fundamental aging processes. And the source emphasizes a really striking estimate that lifestyle factors like these account for maybe 80–85% of your potential results in terms of longevity outcomes.
80 to 85%. That's a massive number.
It is. It suggests that these foundational, accessible habits far, far outweigh the impact of most supplements or therapies currently available to the general public. Despite all the confusing information out there, the source kind of implies it's never been easier to implement genuinely impactful strategies for health and potentially slowing aging through these accessible habits we can all work on.
It offers a much more grounded, evidence-based path, definitely. However, it does circle back to that significant, maybe sobering point raised earlier about the potential for future technologies, right? Like the
Yeah.
gene therapy or protein treatments.
Yes, it does acknowledge that challenging prospect, that as genuinely effective biological interventions emerge, things that might really move the needle on maximum lifespan, they could potentially create significant inequality in life expectancy based purely on wealth and access. Who gets the cutting edge treatment?
That's a profound point to consider as this science develops rapidly. So the big takeaway from this deep dive into the source material seems pretty clear. Maybe reconsider relying solely on the popular blue zone narrative because the data it's built on might be unreliable, or at least questionable. Instead, maybe focus on gaining insight into your own biological aging process and rigorously applying those lifestyle pillars like improving your fitness, especially VO2 max, optimizing your sleep, ensuring a nutrient-dense diet, all based on the robust evidence we have.
Exactly. And understanding the why behind aging at a biological level and what truly impacts that process, even with all its complexities and emerging science, that gives you far more potential agency over your own health trajectory than simply trying to copy habits from potential and misunderstood populations based on shaky data.
Well, thank you for sharing the source material that allowed us to really unpack all of this today.
Yeah.
It's certainly a powerful reminder to look critically at the evidence behind popular health claims.
Absolutely. And maybe as you, the listener, consider everything we've discussed today, here's a final thought from the material to mull over. As technology advances so rapidly in our understanding and potential manipulation of the aging process, how do we as a society ensure that this progress benefits everyone equitably and doesn't just exacerbate existing health disparities? And maybe what part do these accessible foundational lifestyle changes, the things most of us can control, play in bridging that potential gap regardless of who gets access to future technological breakthroughs?